Okay, ladies and gentlemen, this is body weight versus backpack weight. I'm going to go over on the Casio how to do a residual plot as well as conduct a LSRL. Okay, first thing you have to do is make sure your data is put in the calculator. What we're going to do is we need the y-intercept. So we need the point 0a, and we need the point x bar and y bar, or x bar, y bar. Okay? Now remember, this one comes from y hat equals a plus bx. Okay? So we're going to concentrate on that. Now, one of the things you got to realize is that this particular thing, we won't be able to use this right here because we start an x of 0 or 100 and a y value of 20. Okay? So you won't have an x value of 0. So you're going to have to adjust accordingly. All right, so let's go ahead and use our calculator. I'm going to get to the data that we need to. All right, here's our data. We're going to hit graph, which is F1. We'll make sure it's set up. Stat graph F1 is a scatter plot between L1 and L2. So I'm going to go ahead and exit graph 1. I'm going to hit calc, X, A plus BX, which is F2. And here's our equation of the line. Y equals 16.3 plus 0.09. All right, so we've already gone over this. I'm going to go through here. So my equation of the line is y hat equals 16.3 plus 0.09 x. That's the equation of the line. But however, the y-intercept would normally be 0, 16.3. But as we've discussed earlier, we only have the 100 and the 20 as our minimum values on our x and y axis. So what I'm going to have to do is I'm going to have to go back to the calculator. I'm going to hit copy, enter or execute, and draw. Go to menu. Go to number 5. You're going to select it, F1, and you're going to draw. Now recall that our lowest x value is 100, so I'm going to hit Shift F1 for trace, 100, and when x is 100, y will be 25.3. Okay, so we're going to go label that. 25.3 is going to be about, let me erase that, make a better mark. 25 is about there, so about 25.3 right there. Okay. That's going to be our y-intercept for this problem. Now the next thing we need is x bar, y bar. Your LSRL always goes through that point. So I'm going to go back to the calculator. I'm going to go back to menu. I'm going to go to number 2, statistics. I'm going to hit calculate, which is F2. I'm going to hit 2 variable statistics, F2. X bar is 136.1. Y bar is 28.6. So the other coordinate point that I'm going to use, let me mark this down, is 136.1 and 28.6. That's my X bar, Y bar. My Y-intercept was 100, 25.3. So I'm going to use these 2 coordinate points to create my LSRL. So I'm going to use this feature here. So 28.6 is going to be about right here. And 136.1 is going to be about right there. And so I'm going to mark a point right there. And I'm going to connect those 2 lines. All right. Do the best I can with that. The best I can with that. Okay. Now, the next thing we're going to do is we're going to create a residual. Remember, your residual is the distance from a coordinate point down. I'm only going to do one on this one. So I know that this coordinate point is 165. It's this point right here. 165, 35. I know that this coordinate point right here is going to have the same, this one right here, is going to share the same x value. So I need to find the y value that corresponds with that. And what I'm going to do is I'm going to go back to my calculator. I'm going to go back to menu. I'm going to go back to number 5, graphing. Now, as you can tell, I'm going to go ahead and graph it. I'm going to go into the shift trace mode. And as you can tell, you have these lines and you have your little cursor there. So I want to type in 165. Execute. This is the predicted y value. When x is 165, the y value will be 31.25. So I'm going to use that value. All right. 31. I don't want to be bound here. All right. So 31.25. Okay. Now, you're going to use these two values. Okay, you're going to use this value and this value. The first one, this is our observed data. This one will be our predicted y value. And what you do is you take your y minus your predicted value. So your observed minus your predicted. That's going to be 35 minus 31.25. And that gives you a residual of 3.75. That is how you find the residual by hand. In order to find the residual using the calculator, go back to the calculator, go back to menu. I'm going to go back to statistics, number 2. All right, from this section right here, you have to hit Shift, Menu. This is actually the setup for your statistics. Go down to Residual List. You want to hit F2, and you want to change that and put List 3, because when you exit out of here, notice that List 3 is empty. So you want your residuals to go in List 3. Your residual, again, is the distance from the observed value to the predicted value. The predicted value is where is y on the line of best fit. All right, so now you have to go through the entire process of finding the line of best fit. F1 for graph, F1 for graph 1, calculate, x, a plus bx, copy, execute, draw. Now, when you exit out of there, you will notice that you will have your residuals. And as you go over here, notice when x is 120, your residual is negative 1.16. When you go down to 187, it's negative 3.244. Now, when you go down to 165, like we were at, notice it's the same, approximately the same residual, 3.75. So since it's positive, this coordinated point would be above the line of best fit. Now, the next thing I want to do is go back to this. We need to create a residual plot. And the way you create a residual plot is this, all right? Now, here's a couple tricks. If your residual plot, when you plot it, if it's just a scatter plot, this means that it is linear. This is how you prove whether or not the data that you have is linear. If, when you create your residual plot, if it shows a pattern and it's very distinct, it could be like that, or it might even be a pattern like this. If you see any type of pattern that is very distinct. This means it is not linear. Okay? It is not linear. So that's how you either prove or disprove whether or not data is linear. Okay? Now, what I'm going to do is I'm going to go back and show you how to plot the data. Now, according to our data here, now this is your x values. So remember, 100 is right here. So 110, 120, 130, 140, 150, 160, 170, 180. I know it's a little off. It looks a little off, actually. It got a little wider, so try to be a little bit better consistency than I am being. Now, your y values, here's 0. Now, if you look back at your calculator, look at your residuals. The largest is 3.75, which I'm at right now. If you go up a little further, you'll see that your smallest is negative 3.24. Well, since your largest is 3.75 and your smallest is negative 3.24, what you want to do is you want to write these numbers down. So there they are. You want to go above and below to a good number that whenever you put your tick marks here, if you notice, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so this is 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. This is how you're going to measure your residuals, and we're going to plot these points, okay? Let me go ahead and get rid of that. Now, here we go. What you're going to do is you're going to plot your residuals, okay? So you'll have to go back to your calculator, and once you go back to your calculator, you're going to plot L1 versus L3. L1 versus L3. So that's what I'm going to plot on the residual plot. All right, so here we go. Now, for when you have 120, okay, at 120 it's going to be a negative 116. So here's 10, 120, negative 1.16. So that's going to be about right there. The next one at 187, 30, 40, 50, 60, 70, 80, 187. You're going to have it around negative 3.24, so it's going to be further down here. The next one down, 109.16, 103, negative 1.6, so about right here. And as you keep going down your list, you're just going to keep plotting your points. So this one. So that one's above the line. 165 is about 3.75, so up here somewhere. 158 is at 0.3, so about right here. And then finally, 116 at 1.2. Now if you notice, there is no pattern with this. So we have just verified that this is linear because there is no discernible pattern. Now, how would I do this on a calculator? Well, it's easy. What you're going to do is from this method, from here, you're going to hit F1, which is graph. You're going to set up your graph. Now, notice we're in stat graph 1. I want to hit F2 to set up stat graph 2. I want it to be between list 1 and list 3. So hit your list, type in 3, and now you have list 1 versus list 3. Exit out of there. Go ahead and hit graph 2, and there's your residual list. And as you can tell, there is no pattern, therefore it is linear. Okay? The next thing I want to cover is your R squared. Okay? R squared. Now, let me just reiterate. You have one thing called lawyer talk. Okay? Now, where do you find R squared? Well, I think we've all seen it. There we go. All right, R squared. So if I hit exit, I'm going to exit out of here. Remember, you can hit Calc, Reg, F1, A plus BX, and there it is. Your R squared is 0.63. It's this little portion right here. Okay? That's your R squared. Now, remember, your R value only tells you strength and direction. Therefore, this is almost 0.8, so it's strong, and it's positive. It does not tell you whether or not it's linear. That's why you have to do a residual plot. The R squared tells you how well your graph describes the data. Okay? So ours is 0.63. So let's go ahead and go back to here. So R squared is 0.63. Now, you got to write it in the context of the problem. Basically, what this means is the percent change in Y that can be, let it catch up, accounted for by the LSRL of Y on X. Now this is like legal jargon, okay? What I'm going to do is I'm going to show you how to write it in the context of the problem. So we're going to group that together. Okay, let it catch up with us. Okay, so basically I'm going to fill in some points. The percent, we're going to change this to a percent. So 63%. Now the change in Y, think about your problem. We are talking about backpacks. So the 63% of the change in, let's let it catch up for a second. So 63% of the change in backpack weight can be accounted for by the LSRL of the Y value. So I'm switch Y and X of backpack weight on, and then our X value, I'm going to let this catch up again, on, and then X is our body weight. Alright, so 63% of the change in backpack weight can be accounted for by the LSRL of backpack weight on body weight. What does this all mean? Well, what it all means is this. Alright, there we go. What that means is, here's your line of best fit. Alright? Here's backpack weight, and here's body weight. Okay? So it's just like slope. Whenever we increase, so the change in Y, so this change here, 63% of the change in Y can be accounted for in the change of X. Okay? of the line y. This is y on x. So 63% of the change in the backpack weight, change in backpack weight, can be explained by the change in the body weight. What that leaves is 37% is going to be explained by such things as maybe the person is taller, maybe the person is in better shape, maybe the person has a disability such as maybe they have one arm or one leg and they can't carry as much. So the other 37% is being accounted for other items. And that there is going to take care of your percentages, your R squared, and your residual plot.